Hi everyone, welcome back. So in our mini roadmap, we are somewhere around here. In the previous videos, we talked about the basic commands and file system structures and things like that. We do need to talk about the text editor Vim, but I guess we will talk about that after this one. So in this video, we're going to talk about user management. So before we get started, you might be thinking, as a DevOps engineer, why do I need to know about user management, or why do I need to know about permissions? Because as someone who is in charge of the infrastructure, you are the one who should be taking care of all the permissions. Or sometimes you will be the one who is actually handling the users for your infrastructure. And in most of the companies, there won't be a security team, so it's up to you to ensure that the system is secure and you're giving the proper permissions. You are not opening up, or you're not giving more permission than that is needed. Also, you don't want to copy paste chmod commands randomly from the internet and run it on your production server without knowing what it does. Now, how many times have you seen in any internet forum where people suggest you just do chmod 777? So it's extremely important to understand how the permissions and the user management works in Linux. So let's talk about user management. So every user in the Linux system will have something called a user ID. 0 is reserved for root user and 1 to 999 is reserved for system users. So all the other normal users, the value is from 1000 and above. Nobody needs any introduction about the root user, which is the super user or the administrator user. Basically, root has all the permissions in the system and it can actually do anything that can be done on Linux system. Now let's go back to our Linux system. I have SSH'd into our Debian virtual machine. There are two important files that are actually crucial to user management. The first one is /etc password. And the second one is /etc shadow. The first one contains the username, home directory, etc. The second one contains the very important thing, which is the password hash. Now let's take a look at how exactly it looks in a Linux system. So now back to our Debian virtual machine. If we do a cat etc password, now there are a lot of users in here. Here we can see the root user. This is the user ID and this is the group ID. And this is the home directory. This is the shell. So here you can see other other system users, www data, backup, or nobody, or sshd, etc. And here you can see this is the first normal user or first local user, which is named Mansoor, and the user ID is 1000. Now the other important file is etc shadow, which obviously you cannot open without root permission because it contains the password hash for all the users. So let's switch to root user. So here there are only two users with the passwords, which is the root user and the Mansoor user. So this is the password hash. Now I'm not going to explain what exactly this means. You should do the research on your own. So let that be an exercise. So research about how the Linux password hashing works. This actually includes knowing what exactly hashing is and the basic concepts of hashing. Okay, now let's create some users. The command used to create user is add user. There is also user add. You can use either of them. Remember, you need the root permission to be able to add users to a Linux system. Now let's create a user, let's say foobar. And now it's going to ask to enter a password. I'm going to give a simple password. You can fill in all this information if you want. I'm just going to skip. So we have created the user. So to check for any existing users, you can use the grep command and the username. You just grep into the password file, etc password. Here, as you can see, we have created the user foobar with the user ID of 1001. Now if we take a look at the shadow file for the same, here as you can see, it has a password hash also. You can use the user add command also. For example, user add foo Now this is not going to ask you to enter a password or anything, it will just simply create the user silently. Now it's up to you to set a password for it. You can use the command password space the username to set a password. Remember, you have to be either the root user or you have to be the same user to be able to set a password. So if we take a look at the etc password, here the user is created. Now there are a lot of options with user add and add user that you can use to simplify your user creation. For example, you can specify a shell, you can specify the home directory and things like that. You can research about that. So take a look at all the options that user add and add user provides. So Linux also has something called groups, which is a collection of users. For example, if you have a Linux system that you want to give access to a group of people, like developers, you want to classify developers into a group and give them a common permission, or you want to give access to the QA people or things like that. Basically, groups lets you have a common permission across a bunch of people that belong to the same group. You can use the command groups space the username to see the group name. Here, foobar is actually part of the group foobar itself. If we take a look at the root user, you can see root is part of the group root. Another command that we actually use to get elevated permissions is the sudo command. By default, sudo is not installed in Debian 10. We can easily install it using apt-get install sudo. Okay, sudo is installed. Now if we take a look at the man page for sudo, it says execute a command as another user. So it allows the permitted user to execute a command as a super user or another user. Most of the time though, we use sudo to actually execute commands as the root user. For example, right now I am the root user. Let me switch to my normal user. And if I try to execute any command with sudo, let's say sudo ls, now it's going to ask me to enter the sudo password. If I enter it, it's going to give an error saying Mansoor is not in the sudoers file. This incident will be reported. Even though we installed the sudo, we haven't given the sudo permission to my user. Let's fix that. Now switch to root again. The easiest way to give sudo permission to a user is to add the user to the sudo group. We can do that using the command usermod. Let me clear it. Let's take a look at how we can do that just by reading the man page. Here, usermod has this option called -a, add the user to the supplementary group. Use only with the -g option. So let's see what -g says. Yeah, okay, -g, a list of supplementary groups. Now it's important to know that here, if the user is currently a member of a group which is not listed, then the user will be removed from that group. This is why we use the -a option, so that it doesn't remove the user from any existing group. So we can easily add our user to the sudo group using usermod -a. You can give -g, or you can just combine them like -ag, and then the group name, which is sudo, and then the username, which is Mansoor. Done. After adding the user to the sudo group, we need to log out and log back in. Okay, now that's done. Let's try running a sudo command. Yeah, so that works. Let's see if we can open the shadow file. Yep, we can. So that's how you add the user to the sudo group. Also, you can use sudo to switch to the root user without having to know the root password. For example, you just do sudo su root. There you go. You can use the user del command to delete the user. User del space the username, let's say foo, and done. That's it. There is not even a confirmation asked. Let's try and delete the user foobar. But the thing is, it doesn't delete the home directory of the user by default. See here, it still exists. So looking at the man page, you can see we can use the -r switch to remove the home directory also. So that's it about user management. Now let's look into the permissions, Linux permissions. So there are 3 different permission groups. The first one is owner, which is denoted by O. Second one is group, which is denoted by G. And the third one is all users or other users, which is denoted by A. And now there are 3 different permission types. First one is read, second is write, and third one is execute. Now every file in the Linux system has permissions and permission groups set like this. We just talked about groups and types of permissions. Let me explain what exactly it means. Let me switch to the normal user. Let's create a directory called permissions. Let me create another file. Okay, so we have created a file. So now this is the permission for the file. If we take a look at the whole line, this is the permission and this is the number of hard links to the file. Don't worry about it. Actually, you can do a research about hard link and soft link. Okay, back to the terminal, and this is the user, this is the password, this is the group, and this is the size of the file, and this is the timestamp of the file, modified time of the file, and this is the name of the file itself. So this is what we are interested in at this moment. Let me write down that permission here. -r w -r -r --. So now this is how they are classified or grouped together. This first one is the owner or the user permission. The second one is the group permission. And the third one is the others permission. So let's denote it with U and G and A for all users. And this one is the special permission. If we come back here, read is actually denoted by R and write is denoted by W and execute is denoted by X. So here RW means read and write. R ---- means read only, because we are not giving any other permission here, only read permission, and this is also read only. So remember, the position of these characters do not change. I mean, you will never see a W coming in the first place here. It will always be on the second place. Now you can modify these permissions using the command chmod. Now let's take a look at what exactly happens when you do that. So here, as you can see, this one has read, write, and no execute permission for the user. This is the user part, and this is the group part, and this is the other part. To give the user the execute permission, I can give chmod u, which is the user, plus x, which stands for the execute permission, and then the file name. Now if we take a look at the file again, here as you can see, an X has been added, which stands for the execute permission. It still does not give other users or other groups any more permission than it had before. Take a look at here for comparison. So now I can give the groups the write access, G for group plus W for write access. Now if we take a look at here, as you can see, the group now has read, write, but no execute permission. So now let's try and give the others the execute permission. Here, the others now have execute permission, but it does not have any write permission. So to be able to actually modify a file or delete a file, you need to have the write permission. Just with read permission, you can read the contents of the file. For example, you can use cat or less to view the contents of the file, but you will not be able to modify the file. And what exactly does this execute permission mean? Well, it means to execute the file. For example, if I create a simple script, let me create a simple script. I will explain what exactly this means in another video. For now, let's just create a simple script. Now to execute this file, we do dot, which corresponds to the current directory, then slash and hello.sh, which is the file name. But now as you can see, it says permission denied. Now why is that? That is because by default the file does not have the execute permission here. So now if I give, it changes the permission bit here and I can execute the file. Okay, now let's create another directory. Here with ls, if you use the d command, it will not list the contents of the directory. Instead, it will just list the directory itself. Here I wanted to see the permissions of the directory itself, not the contents. So that's why I used the -d. Here we can see something is different. First of all, the first dash is replaced with d, which corresponds to a directory. And you can see that previously when we created a new file, for example, if I create a new file, let me just clear it and make it easy. We needed to see the file AA. This new file does not have the execute permission, but this directory does have execute permission. So what does it mean? When it comes to a directory, execute permission means the ability to open the directory. So what happens if I try to cd into the directory? Well, I can cd without any problem. Now let's try to remove the permission, the execute permission. You remove the permission by using minus the permission. So now u minus x will remove the permission for the user. Here as you can see, the execute permission is gone. Now if you want to remove the permission from all the users, you can give here as you can see, it removed the execute permission from the user, the group and others too. So what happens if I try to open the directory now? Well, it says permission denied. So that's why the directories have this X or the execute permission. So far we used chmod, u plus x, u minus x, u plus w, or o plus w, or o minus r, etc. But this is still not the best way to do it if you want to change the permission for a file and you want it to be definitive and you want to change the user, group and the others permission in one go. And that's why we use the octal notations in permissions. This is how it looks. So in octal notation, 0 means, well, in decimal it's 0. So in binary it is 000. So file mode means no permissions at all. And 1 means in binary it is 1 and file mode is X. So here is how the permissions values are: read, write and execute. Read has a permission value of 4, write has a permission value of 2 and execute has a permission value of 1. Now where does it come from? It comes from here. This is the octal notation of this permission and that's where these numbers come from. See, here we have 3 characters, right? And there are 8 combinations of these characters and that's why we use octal notation for the file permissions. So dash 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 means no permissions, which is equivalent to 0. And here, as I said before, the execute permission has a value of 1 and write permission has a value of 2. Write and execute will have 2 plus 1, 3. Now read alone has 4. Now read and execute will have 4 plus 1, 5. Read and write will have 4 plus 2, 6. Read, write, execute will have 4 plus 2 plus 1, which is 7. So what exactly does it mean, or how do we use it? For example, if you do chmod 777 file.txt. So remember, this octal value is for per character. What I mean is, when you give it like chmod 777 filename.txt, the first one is for user, the the second one is for group, and the third one is for others. So 777 means the user has a permission of 7, group has a permission of 7, and others have the permission of 7. Now what does 7 mean? 7 means read plus write plus execute, which is what we explained here. So basically this means 777 means everyone has read, write and execute permission on that file. So what does 644 mean? 6 means read plus write and 4 means read. So this means the user has read and write permission and the group and the others have read only permission. Now let's use chmod with Octal permissions to change the permissions of these files. Let's start with chmod 000. What happens if you set 000 on a file? Here as you can see, it has no permissions. It's completely gone. Similar to what we have here. If we set chmod 777, now it has all the permissions. RWX, RWX, RWX. Similarly, if we try chmod 644, this has the read write read only permission. So that's how the Octal notation permission is used. Now you can use the command stat-c in single quotes %a, close the quotes and the file name to see the permissions in Octal format for that file. Now you can read about how exactly this works in the man page for stat. So far we talked about changing the permissions of a file. Similarly, we can change the ownership of a file too. For example, if you look here, all of these files are owned by user Mansoor. We can change this to any other user we want. Let me create another user. I don't have to switch to the root user. I can just use sudo. Okay, so we have created the user. And here we have a bunch of files that are owned by the user Mansoor. Now let's try to change the ownership of this file. You use the command chown, then the username, let's say foo, and then colon, the group name, then the file that you want to change the permission to. Okay, sorry, it's under the perms directory. chown, user, colon, group, file name. Aha. Now if you look here, it says changing ownership is not permitted. Well, that is because root user is the only one who is able to change any group or any ownership of a file. Basically what it means is you cannot change the ownership of the file even if you own it. Only root can do that. Now let's try sudo chown, username, colon, group name and the file name. Now it has changed. Now as a pro tip, you don't have to actually type in foo colon foo. You can simply use, if you are using the same group name, you can simply use a dot to change the group to the same name as the group name. That's about it for the user and permissions. See you in the next one.